Good morning. Hello all. Good morning. In continuation of my day 9 Kafka discussion, let's proceed further with question answer. So today's question is, how does Kafka handle massive data storage and retention policies? Apache Kafka is designed to handle massive amounts of data efficiently. Its architecture and configuration options provide ways to store large volume of data and define retention policies. Here is how Kafka manages these aspects. The first thing is distributed system. So Kafka operates as a distributed system, which means data is spread across multiple nodes, which is in Kafka called brokers, and the set of brokers is called cluster. This distribution not only provides a scalability, but also provides fault tolerance as data is replicated across multiple brokers. Another key important point here to understand, these supports immutable logs. So each Kafka partition is essentially an ordered immutable sequence of records or logs. Once a record is written to a partition, it cannot be changed. That is what immutable says, right? This design ensures that write and read operation are efficient and same time as data is always append to the end of the log. So it is very, very high performant. And that is the beauty of, that will help you to reach the highest level of scales. Okay, and that is how Kafka is designed by the architect. So that is the good point to take in your consideration. Okay, so you just discussed distributed system and immutable logs. Let's continue with segmentation now. The logs in a partition are divided into smaller files called segments. This segmentation helps manage older data and makes deleting expired data efficiently. Another which is very important point to understand is retention policies. Please note that Kafka is providing multiple level of retention policy. These are like time-based, size-based, and so on and so forth. So let's start with time-based retention. Kafka allows you to specify a time-based retention policy or topics for you. For instance, you can configure a topic to retain messages for 7 days, and that is log.retention.hours is equal to 168, which is 7 days. After this period, the old segment contains the expired message will be marked for deletion. Then another key important configuration concept here is size-based retention. You can also set the retention based on the total size of the stored data. For example, you can configure Kafka to retain up to 50 GB of data for a topic. And once this limit is reached, the oldest segments are deleted. Okay, so you just discussed time-based and size-based retention policy. Let's continue with log compaction now. Kafka offers log compaction as a retention policy, which retains the latest value of a specific key. It's beneficial for topics that store data like database change logs, where you might only be interested in the latest value of a specific key. Log compaction ensures that Kafka retains its at least the last known value for each message key, right, within the log of data. So let's start now the next concept as data cleanup. Data cleanup can be considered like once the data matches the deletion criteria based on maybe size, age, or log compaction, the segment contains this data are deleted or compacted. This message happens in the background without affecting the ongoing Kafka operations. We discussed, I think people are a little confused about the compaction. So please try to understand that log compaction has only meaning when you have a append kind of concept. Why? Because just consider the use case where you are writing every time one key value pair, which is just like to update you that your system is up and running. Let's imagine this virtual scenario. So in that case, can we have to maintain all these things, or it is only meaningful for you to maintain the last updated one, which is actually referring it that your system is up and running until this point. So I hope that now you are very much clear about why log compaction is we discussed here. What is the scenario? Okay. I hope I'm clear now. Okay. Okay, let's start the next concept as replication. So as the name suggests, replication is to ensure data durability and availability. Kafka replicates each message across multiple brokers. The number of copies is defined by the replication factor. Even if a few brokers fail, data is not lost in that case. Another important thing is tuning for large scale. For massive data storage, appropriate hardware and configuration are necessary. Using fast storage like SSDs Adjusting OS level page caching and tuning Kafka producer and consumer batch sizes can optimize performance. Properly tuning and increasing the number of partitions can help in distributing the data more efficiently across brokers, improving parallelism and scalability. Okay. Another topic is storage efficiency, how you Kafka achieve this. So Kafka allows message compression, which means producers can compress messages before sending them to brokers. Supporting compression type includes gzip, snappy, LZ4, ZSTD. Compression saves basically a storage space, right, and reduces the amount of data transferred between producer and broker and consumer also. It helps, right, to store more and more data to Kafka. So I hope by now you are clear about the following concepts of Kafka architecture assumption done by their architects. And these are distributed system principle followed inside Kafka. What is the value of immutation logs in Kafka? Segmentation. What are the retention policy followed? Data cleanup done? Replication done? And the most important thing is how they have tuned requirement or required for large scale or storage efficiency with compression. These all are part of Kafka architecture, which is making them a very, very powerful engine, very, very powerful streaming platform. At last, I would like to conclude it by saying, in essence, Kafka design principle, configurable retention policy, and scalability features allows it to handle massive data storage efficiently. Proper tuning and understanding of these configurations are crucial for organizations to make the most out of Kafka in large scale scenario. So I hope by now you are clear about the following concepts of Kafka. Alright, so let's close this video here only, and let's meet in the next video for part 3 in Apache Kafka. तब तक के लिए पढ़ते रहें, सीखते रहें और बढ़ते रहें. आपकी मेहनत आपके साथ होगा तो ही आप आगे बढ़ पाएंगे. तो इसी के साथ मैं इसको अंत करता हूँ, इस वीडियो का अंत करता हूँ, और फिर हम मिलते हैं अगले वीडियो के अगले पड़ाव पे. धन्यवाद.